Foothill Associates. We're environmental consultants. I'm a landscape architect. I do a lot of environmental planning and design. And when we first proposed this topic of working landscapes, we don't call what we do creating working landscapes, but the more we talked about it, the more I realized that at least this type of project, we do a lot of vernal pool creation, and this particular project was an interesting specific example of taking kind of a single-purpose landscape. It was a heavily grazed, laser-level field, and creating a vernal pool complex which supports habitat. It's still grazed, as Justin said, and it's really creating reconnecting the systems that run on the land back to a more natural state. So this was a vernal pool project in southern Sacramento County down by Wilton. Just a quick set of terms. When we do vernal pool creation, we refer to it as there's two different types. Construction is if you're putting new pools into a landscape that has existing vernal pools, but you're putting it in areas where vernal pools have not been. And then restoration is taking a disturbed landscape that used to support vernal pools and then creating vernal pools on it. For those who don't really know what a vernal pool is, it's a wetland. This is a little 1-minute, 2-minute primer on how a vernal pool works. You have this is your soil profile. You have a soil with a hard pan underneath. It's either a clay pan or a durapan or bedrock, something that forms a confining layer that water can't move through. It rains, your water slowly saturates the upper levels of the soil and pools on top of that hard pan. In a natural landscape, you're going to have natural depressions, and as that water increases in depth, they fill up those depressions, and it creates wetlands. In an artificial landscape where it's been leveled, those depressions have been taken off. So when we create a vernal pool, we basically scoop part out of the soil, and to get us closer to that hard pan, so that when it rains, you actually get the water pooling in the vernal pool. So that's a little 1 minute on vernal pool hydrology. So when we look for a landscape to restore, we're looking for a disturbed site. We want something that's been, where most of the habitat value has been wiped out, because at least in this case, you'll see it's a fairly invasive process to go in and recreate these vernal pools. And we don't want to destroy any habitat that's there. You can do it with a site that has existing vernal pools, but you have to be really careful and fence your vernal pools, make sure that your existing vernal pools don't get impacted. And we definitely need that second topic is probably the most important, is to find a site that has relatively intact subsoil. The hard pan or the clay pan has to be intact. It has to be an impermeable layer. If the site has been deep ripped and that impervious layer has been disturbed, it's not going to work. So we first did, for this particular project, we first did an analysis looking at all the disturbed agricultural lands that have been leveled in Sacramento County. We settled on this one site. This is a picture, I believe this is a picture of the actual site here on the left and the adjacent preserve on the right. So the site on the left used to look like the site on the right, but it had all been laser leveled so that it could be flood irrigated for pasture land. So what we first do when we go out there is we send our soil scientist out there and he digs a bunch of pools, a bunch of pits with a backhoe. He's looking for that clay layer, he's looking for the depth to that clay layer, and he's looking for how intact the clay pan is. So I think on this site he probably dug 60 pits maybe actually probably 30 pits at first, and then he went in and did a more detailed investigation later. Wow. So then we can set the depth of, when we do our construction documents to design the pools, we can set the depths of those pools. When the excavator goes out there, we can dig them to the correct depth. Just some of our basic design considerations. Basically use a variety of natural pool shapes, incorporating the excavation soils from the impact site. This was mitigation for a development. So there was a big development that was going in Rancho Cordova area. Impact was impacting existing vernal pools. We need what we call an inoculum. It's soil out of your existing vernal pools that has the cysts for the crustaceans and the seeds for the plant that you want to recreate in your new landscape. We call that inoculum. You need that soil to inoculate your new pools so that they're successful. You can probably do it without that soil, but their success rate is lower and it takes a lot longer for those communities to establish that you have that inoculum. And then utilizing your natural topsoil when you scoop out these pools, you can use that topsoil to spread around on the denuded areas of the site, or if you need to do some additional restoration. So this is just a little design here. We just took, the impact site is on the left, so we took natural shapes of those pools from the impact site to create our restoration design. So the rest of this talk is mostly on construction and response. This is the site before we started, so you can see it's been laser leveled. There's no wetlands on this site right now. It's all grazing land, flood irrigated.
So was that ag land that the developer purchased for the purpose of mitigation?
The developer purchased it from the farmer who had laser leveled. Well, it was either purchase or lease, I don't remember which, but I think it was purchase. Yeah. And this is about a 200-acre site. So here they're out there. We use big equipment. For this scale, we're creating 30 acres of vernal pools. There's 300 and some odd vernal pools we're creating on this site. We use big equipment. Scrapers basically go in first, and they excavate out the surveyor goes in first and stakes the perimeter of all the pools we're going to create. Then the scrapers go in there, scoop the pools down to about the right depth, and we have monitors on site and our soil scientists on site to verify that the clay pan is not breached when they're doing this digging, so he can tell them how deep to go and stop them. He was actually out there with a backhoe digging the pits in every single pool location before the excavation was done to make sure how deep he needs to go and to set that elevation. And then we have our surveyors, or our staff out there measuring the achieved grades to make sure that they're close to what we thought they should be. And then we have, this doesn't show a road grader, but there's one here. He goes in and does the fine grading after the scraper's done, because the scraper doesn't have a lot of control. And then we have tractors go in and drag it afterwards just to smooth out the dirt. And but you can see it's pretty intensive. I mean, this is pretty much disturbed land as far as the eye can see.
When they're shaping a vernal pool, are they doing kind of free form based on the trace, or is it like a CNC technology? Or?
We've had the surveyor stake it, so they know basically the shapes we were planning on when we designed it, and they'll pretty much stick to those shapes. But the rest of it is kind of an art form, you know, how good they are at, you know, reading it. And we're usually there saying, well, can you take out a little bit more here, or reduce the side slopes, or you know. And we did do in this particular project, we did a lot of on the ground adjustments, so that, like I said, our soil scientist was out there digging a pit first. If he dug a pit and for some reason did not find a clay pan, the clay pan was disturbed, we'd abandon that pool and, you know, put another one over here, or increase the size of one of them over here, basically because you don't know. This is a blank slate, you know, because it's been laser leveled, you don't know what the clay pan is doing underneath. If it was an undisturbed landscape, you could pretty much assume that the clay pan is mostly following the edge, following the topography of the surface, and it's going to be intact. If it's intact in this place, 30 feet over here, it's probably going to be intact. 30 feet over here, it's probably going to be intact. With a leveled site, you don't know what it was doing before they leveled it. So there has to be some.
What's the thickness of that top layer on average?
I think here we were anywhere from 12 inches down to 60 inches. I think it was probably our deepest. We found one area where there was like a natural ravine in the topography that had just been covered over.
Was that a remnant channel, do you think?
Well, I don't know, because there was clay pan under there. If it was a remnant channel, you would have thought it would just be alluvium with no clay pan. There was a clay pan down there. So, I don't know. It might have been just that it just didn't have the alluvium.
And I was told that by a biologist that you want these vernal pool lands to be fairly heavily grazed. You do. Because it compacts the soil.
Yeah, the graze.
Without grazing all the gophers and...
The footprints can compact the soil also, as Justin said. If you get too much growth, vegetation growth, the evapotranspiration just pumps your pools dry too quickly. When it starts warming up in April and May, all the water. In fact, we saw that on this site. For the first year we didn't graze it at all because we wanted the vegetation to come back. Because as you can see, it's pretty much denuded. So we didn't graze it all the first year. The second year, we got the cows out on one of the fields. There were two fields here. We got the cows out on one of the fields much later than the other field, and those vernal pools dried out a lot. Didn't have the inundation regime that the heavily grazed pools had. They were actually, they wetted up later and they dried out quicker.
I don't want to disturb your presentation, but there's kind of a question. I was talking with somebody who was involved in extreme conservancy, and they were invited to come to the tonight and share. And they said, no, we're dealing with ecological services to the natural environment, and these aren't typically seen as an economic development value. So, you know, I'm really curious about the relation between conservation lands, stream zone protection, habitat protection, et cetera, and how we translate that into what our economic interest is in preserving all those values. How do you make the connection?
I'm sure I have an answer to that. I mean, this is very economically driven because this is mitigation for a development that was impacting vernal pools. They're trying to sell houses, right? So the demand for houses is creating the development. And this actually, you know, even though there were fairly high quality vernal pools they impacted, it was in an area that was all going to be developed. It was in, you know, the Sunrise Douglas expansion area, Rancho Cordova. It was for houses. And so do you preserve, the question is, do you preserve, you know, a smaller preserve in the middle of all these houses? Or do you set aside a larger area? This is about 200 acres. It's adjacent to 2 other mitigation banks. So there's probably 600 to 800 acres here that have all been preserved with vernal pools. So, you know, yeah, it's I mean, I don't know, you know, it's a...
I mean, I think the larger point would be, I mean, and we dealt with this when I was on the Placer Legacy Open Space Committee, but, you know, the position would be, do we not need a functioning natural environment and all of our natural systems in order to provide the quality of life amenities that in turn make this a place you want to live and work and have jobs and so forth. So you know, certainly at some point, if you're compromising all your natural systems, which in turn, you know, really degrades their ability to function as an open space amenity, then what is that going to do to your economy? And so there's, if you went to an extreme, you could see there's definitely going to be a connection. So I'm not sure the case has been made very well here anyway on why we have a vital economic stake in some of these ecological system functions and natural systems. And maybe that's something we could do more of.
I'm planning to address some of that
Yeah.
in my discussion.
Oh, good. All right,
Yeah,
good.
and I'm just there's trade-offs.
I think your question, though, gets a little bit to conversion of ag uses, because you're essentially restoring a landscape to its more natural condition, which also sustains a different type of an ag use. You know, it had been laser level to produce crops at one point, and now it's being converted to sustain grazing.
Right.
Okay, but at the same time, it's also providing habitat for other ecosystem services, like you had mentioned, that provide a broader range of benefits.
And that'll also bring in, you know, other economic components as well, because how many people want to go out and see an irrigated pasture? How many people want to go out and see a beautiful functioning vernal pool system, or the birds that are using it, or the wildlife? And then if you ask anybody that lives in this area, you know, why'd they move here? The vast majority of them did it because it's beautiful. You know, we have the recreational, you know, components and all that. So, I mean, people travel from Sac just to come up here. You know, so those are those other little values, and you're bringing in a lot, especially in this case, because that's an enormous amount of money into the area. So whether it's federal funds, state funds, just somewhere out of the area, you're bringing it in with these projects and distributing it among the community. You know, when we created pools on Ardoti Ravine Preserve as a mitigation project, the money came in, and one of the local farmers up the road who does this type of work for the agency, you know, he had work. So
I think there's a benefit too towards aggregating these mitigation types of opportunities together, because then you're actually reconstructing larger areas of land, which is sort of reversing the trend of fragmentation, which is more and more prevalent across the landscape.
yeah, we have that study on our website as well, that especially with the vernal pools, the small scale vernal pool protection just doesn't work in the long term, the big landscape scale. So,
Well, one thing is when you're consolidating these interests, you actually are supporting the landscape. Whereas the other way, like even like the Corps of Engineers with wetlands, I know they're very concerned about, to some degree, in-place mitigation because, what's left, the remnants of the wetlands are these little fragmented pieces of wetland areas that if you protect them, they're marginal. Whereas if you consolidate those interests and create a wetland or, that's an actual habitat, you're getting much higher quality. So, anyway, I didn't want to totally, yeah.
Jeannie, you had something?
And maybe a little bit. My question is, so you're designing this, you're engineering this, and who's going to manage it when you're done?
There's a conservation easement placed over the property.
So it's going to
And
be.
the conservation easement has to go to an approved
To the land trust.
C3
Okay.
land management agency. And the developer sets aside an endowment, which is the interest on the endowment is supposed to pay for the maintenance, the management of the land in perpetuity.
So that
there's
ties
no
us back
wasting
into
of-
Justin's presentation. Thank you.
Yeah. And I think, back to the economic benefits, I don't know, it's hard to quantify things like clean water. What's the value of clean water? What's the value of a vernal pool, tadpole, shrimp? What's the value of,
You got it?
yeah, some of those economic, or some of those things have intrinsic value beyond the economy, and it's not always you can always boil it down to dollars and cents. Okay, so this is the knockdown here. This was collected from the impact pools. So it's been deposited in the bottom of the vernal pools, and then that will be spread out about 2 to 4 inches thick of that in the bottom of every pool. Here it's been spread out, and then here it's just started. This was done in 2007, I believe. Summer of 2007, and all the construction was done in September and October. So this is probably late October once it started to rain and things started to green back up. I just threw this in just so you can get an idea. This is an aerial, this is a GIS model of the topography. So this is the pre-construction, pre-restoration condition. There are a few depressions left in here, and some of these were, I said it was totally wiped out. There were a few small wetlands left in this area which we fenced off and preserved. This is what we created.
Oh.
Was there any element of flood control? Because the topography, the change in topography can also help with flood control.
Right. We did not do that analysis, but yes, you are retaining some additional water in storm events.
And
less,
sheet flow.
yeah, rather than it running all off into the creek, you're detaining it on the site. And then this is from 2008. This is year 1. So here we're just starting to retain water in the vernal pools. The uplands are coming back. We had phenomenal upland growth in the first year. This is the first year still.
Wow.
The developer had they were using this as grazing land, so they were over-fertilizing it. So there was a lot of latent fertilizer still left in the soil. And that's why we had this phenomenal growth. That's not necessarily what you want in your vernal pools, but usually the inundation will kill off the grass.
Yeah.
So then after that, we've done basically 6 years of monitoring up through 2013. This last year was our last year. We got Corps sign off. So there's our working landscape, there's our cows. Just various pictures of vernal pools out there. These little blocks you see in some of those are just our monitoring gauges. We just spray painted some concrete blocks and used them to measure the depth of inundation. Just a few more pictures. Here's Rancho Seco. I kind of like the pictures of Rancho Seco.
The density of vernal pools you have here, is that kind of depicts what would be natural?
In some areas, it really varies. Here, we're actually a little higher. I think where you hit somewhere between 15 and 20. We usually try and get more down to 15%. 15 is kind of the max we try and hit now. Here, it's a way to trade off how much land you disturb, and what makes sense in terms of the vernal pool complex that was impacted was in that same kind of density range. So. And these are just some of the plants, pool plants, and the critters. This is all, this is sensitive species driven. So these are vernal pool tadpole shrimp. They're an endangered species, and we had them in our pools, I think starting from year 1, and we have some healthy populations out there now. This is just so this is a live one, and then this is just a cast-off shell.
Is there something that they feed on, or do they provide food source for other animals? When you say they're an endangered species, I'm wondering what the value specifically?
They're just part of the food chain. You know, they do eat. I imagine they eat mostly algae, and other things can prey on them. Little, tree frogs and other critters. But they're federally listed endangered species. Vernal pool fairy shrimp and vernal pool tadpole shrimp were kind of the two drivers for this project.
Okay.
The pools that were being impacted had both these species, and Army Corps of Engineers and Fish and Wildlife Service both regulate. Army Corps of Engineers regulate inland wetland. Fish and Wildlife Service regulates impacts to sensitive species, and so they're basically telling the developer that they have to do the mitigation based on the impacts.
So do they just exist in this place, or do you have to bring
Yeah.
the
Well, they came in on the
frogs to
inoculant.
breed, or, okay?
They're all throughout the Central Valley, vernal pools. So like that's what I was saying. If you bring in the inoculant, then these things they lay eggs or cysts that get into the soil, and then the soil, this vernal pools only last usually from they usually wet up around December, January, depends on how much rain you get. They dry out in April, May. So in that time span, these guys have their whole full life cycle. They grow up, they lay their eggs, they die, and then the eggs can stay dormant in the soil for quite a long time, years.
Kind of a point on the inoculant, which is real important, is like he was saying, you can do it without it, but then trying to colonate those pools can take quite a long time.
Yeah, so it's just have to come in on the air if you do that.
And that's it. And
If
so
you
one
have
of
the inoculant.
the values that we teach the little kids out there, instead of getting all scientific on them, is I relate it to a road trip, the migratory birds. And this is their McDonald's, and this is where they're going to stop, get their chicken McNuggets. And when they're wandering around in the pools, stuff gets stuck to their feet or their feathers, whatever. They go to the next pool to rest, and then they drop those cysts or seeds or whatever. But that can take a long time. Whereas if you do have the inoculant, you can have it first year, bang. And while I was brought up kind of hating the word mitigation and fearing these kinds of projects, now that I manage them and have to monitor them, a big problem we have in Placer County and some of the Sacramento area ones are very shallow pools. With our current drought status, climate change models, that sort of thing, those pools dry up too fast. And if you need somewhere between 24 and 36 days or so for one of these creatures to complete its life cycle and put more cysts down in there, you may not get that during these future climate regimes and that sort of thing. So when you're designing these pools, you can get the depth that you want out of there, so you don't have to rely on these super shallow pools that may never hold anything. Or hold now, but in 5 to 10 years they won't. So
And that's
I'm
something
starting to see value there.
I hadn't thought about with this site. I mean, being a laser level field, we have a whole range of values out here, probably from 12 inches deep all the way up to over 24 inches deep probably. And that gives you probably a little more robustness to respond to different climate conditions.
Ed, were you during the monitoring, was there evidence that the wildlife, the migratory birds did discover it, or were there, and were plants were they restored?
We weren't specifically monitoring for birds. I don't know if our biologists saw them out there or not. I'd be surprised if they didn't, because this is along the major north-south byway. I don't remember seeing that in any of our monitoring photographs, but.
And who holds the easement on this now? Or are you not allowed to say?
I believe this is Sunridge Conservancy, but I'm not positive about that. That's it.
Wow.
This is one of the vernal pools that's in their flowering season.
Wow.
Not one of the ones on this site. This site actually, because it was done in 2008 and 2009, 2010, and I think 2011 too, were really dry. We had several fairly dry years. The vegetation's been slower responding than we had the shrimp write-off, and we had some of the vegetation there, but the cover hasn't been there. In 2011, I think we had a relatively wet year, and I think things started looking good, and then 2010 or 2012 and 13 being what they were.
And our natural pools kind of follow that same model.
Yeah, and that's one thing I didn't mention with this thing. This is as I said, there is a vernal pool preserve right across the road from this, and we picked 10 control pools out of that to use in our monitoring. So we basically compared the response of our pools against the response of the control pools in the preserve, and they basically shown pretty much the same thing. Okay, thanks.
Great.